Now we're going to study about electric field lines. By convention, the electric field around a positive charge is always away from the charge. And if it is a negative charge, then the electric field lines will be towards the charge. So it means that if you have a parallel plate, we have parallel plates. Suppose if this is positively charged and it is negatively charged, so it means that if it is a positive charge, the electric field lines will be always away from the charge. So in order to remember it, you can always remember that from the positive charge the electric field will be away, and for the negative charge it will be towards. So if you have to draw electric field lines between these two plates, it will be from plus, away from plus, and towards the minus. So this will be the direction of electric field lines. So this is electric field. Now if the field is strong field, strong electric field is depicted by lines which are closer to each other. Okay, and a weak field is depicted by lines which are away from each other. They are broadly spaced. Okay, so this will be a weak field. So it means that in positive and negative charge, when we are away, like when we are nearby, then the electric field lines, they are closer together. So it means at this point it will be a strong field. Okay, and when the point is, if the point is somewhere here, the charge is somewhere here, the test charge, then the field lines, they are away from each other. So here it will be weak electric field based on this. Also, let me just tell you about motion of charged particles in a uniform electric field. So if we have uniform electric field and there is a charged particle entering that field, what will happen? Suppose you have an electric field which is uniform, so it means that the lines will be equidistant, and there is a charge which is entering this field, and this charge is a positive charge and it is at rest. Okay, so when this charge enters this field, you know that the electric field line is always plus to minus. So it means that if the electric field is in this direction, it means that the plus is here and minus is here. So this charged particle will experience a force along the field. Now in another situation, if you have uniform electric field and charged particle is positive, but it is in motion and it is entering the electric field perpendicular to the electric field. So this charged particle which will enter the electric field perpendicular to the electric field, then because you know plus and minus will be here, so it is a positive charge, it will get attracted towards the negative, so it will move along the field. So but it has some initial velocity, it is not at rest as compared to this charge. So if this charge is at rest, it will move along the field, but if it is already moving, so it wants to move in this direction, but field forces it to move downwards. It wants to move in this direction, but the field forces it to move downwards. So then it will move in a trajectory which will be something like this. So this will how a charged particle will move if it is charged and it has some velocity, initial velocity. Now based on this, I'll take two problems, maybe in the next video.